What's up guys, welcome back to my channel. And in the last video I mentioned slopes, or otherwise known as gradients, and I'm going to continue that and go into further depth in this video. As I said in the previous video, the slope in the straight line equation is represented by the m, and as I said, this c here could be also represented by a q, but I'm going to be using c in my videos. So what does slope refer to? Slope refers to the steepness of a graph. So essentially, you can think about it as if it were a mountain. So a mountain with a really steep slope would be one that goes up very suddenly, very quickly, right? And this would obviously make it harder to walk up. But one with a more gentle slope, or a smaller slope, would be like that. It would be less steep, right? And I'm going to show you guys a few examples. Okay, so between A or B, which graph is steeper? I'll give you a second to answer. I think it's obvious that it would be B in this case. As we can see, that line is a lot steeper than that line. I'll give you guys a more mathematical way of thinking about it, but for now I'm just trying to build your intuition and understanding of slopes. Which slope would be greater? Note that I'm saying which slope would be greater. I'm not asking which steepness. I'll give you a second to think about it. The slope which is greater would actually be this one, but B would have the steeper line. Let me explain why that is the case. Because both of these slopes are negative. So in both cases, m would be less than 0. But in this case, the slope might be something like, we'll call it m1, might be something like -1. Meanwhile, the other slope, m2, might be -4, for example. And while the 4 is larger than the 1, which is what contributes to the steepness, because the negative is there, the -1 is greater than -4. I hope you guys understand that. On a number line, 1 is greater than 4. Now, I'm going to explain to you a way of thinking about the slope a bit more mathematically. Okay, so now that we have an intuitive understanding of what exactly a slope is, let's get into how we actually calculate it. So in order to calculate a slope, using the slope formula, which I'll show you in a minute, what you require is two coordinates on the line. So in this example here, we have the y-intercept given and the x-intercept given. And we have expressed it in terms of coordinates. And I know that the way I was taught in high school is that to use a semicolon there, but really I don't think that's not like the international convention in my, from what I've seen, that's not, yeah. So what we're going to do is we're going to plug these two coordinates into the following formula. So here is the slope formula, where, remember, m represents the slope, and these values here, I'll show you what they mean in a moment. So the y1 and y2, I actually got them confused there, y2 and y1 refer to the y values of the two different coordinates. So what you can go ahead and do is select one set of coordinates as, coordinate 1, and the other one is coordinate set number 2. So let's say 0, 2, let's say that's coordinate 1, and -3 and 0, let's say that's coordinate set 2. So what you're going to do is, my bad, this is from a previous example, different type of example, but it was, I realized I made a mistake, so I had to redo things. Anyway, we can just plug in the second y value, that's what y2 means. So 0 minus the first y value, which is 2, and then we say the second x value, which is -3, minus the first x value, which is 0, and then what we're left with is -2 over -3, and of course the negatives will cancel out, and then what we're left with is 2 over 3, and that is the slope. As we can see, it's not a very steep slope, it's quite a gentle slope, as represented by the graph, but the graph isn't really to scale. But now you guys know how to calculate the slope, sorry, if you are given two coordinates. And also what we notice about the slope is that it is positive, meaning it's going upwards. So another example would be if you're just given the coordinates and not the intercepts, and you just follow the same process. Note that this is not going to be to scale, so don't judge me if it's if it's not perfect. So that looks like it's -1 and 4, and that looks like it could be 4 and let's say -3. So what we're going to do is we're going to plug it into the same formula. M is equal to y2 minus y1 over x2 minus x1. This is also written as delta y over delta x. What this delta means is the difference. And essentially, I hope you can see that this is just the difference. It's the one minus the other, and that's why it can be written in that equivalent form. So let's go ahead and plug in those values. Let's say this is coordinate 1, that's coordinate 2. And then we have 4 minus -3. Remember, we have to maintain the negative sign. And then -1, let's draw the line, minus 4. And then what we're left with is 4 plus 3, because the negatives become a plus 1. -1 minus -4, that becomes -5. Then we're left with 8 over 5, but with a negative sign. Note that it's negative, and that is reflected in the fact that the graph is going downward. And so that's how you find the slope of a graph. It's not very complicated. There are other examples and other situations where you're not given coordinates, but you are given maybe a part of the equation of the line. But I will make another video explaining those different examples. So the method that I like to use to think about slopes or gradients is the rise over run method, or the rise over run formula, I guess you could put it. The way to think about it is to imagine every slope as a fraction. And once you've imagined it as a fraction, then you have it kind of in this format, the rise over run. And the rise refers to how far upwards or downwards the graph goes in some x distance, which would be left or right. I swap them around actually, right or left. Let me show you what I mean by way of an example. Let m equal to 3. If m is equal to 3, then we can write it as a fraction as 3 over 1. I hope you guys understand that every whole number fraction or every integer fraction is just itself over 1, right? We can say therefore that. And then the way we can go about thinking about it is that for every one x value, let me draw axes. We don't have a c value, so for now let's just say the equation is y is equal to 3x plus, or let's just say it's y equals to 3x. For every one x value that the function moves left, it moves up by 3. So we're going to say 1, and then 1, 2, and 3. And then we have that point there. And then it moves another 1 to the right, and then 3 up. 1, 2, 3. And then we see that the line will join like that. But I hope you see that because of the slope that is 3 or 3 over 1, goes right 1 and then 3 up. Let's say, for example, it was -3. Then in that case, the negative sign it could go either there or there, but not both. There or there. So then it would mean that for every one x value to the right, the graph goes down by 3 y values. So it's 1 to the right and then 3 y values down. So then we have that one, we would have that one. And then we would have a graph that looks something like this. Then you could also complete the other side. This is not a method for sketching the graph. I'm just trying to show you how you can think about the slope in a simple way that is easy to remember. So let's say, for example, that y equals to 3x plus 1. So in this case, the m value is 3, m is equal to 3 over 1, and then we have a y-intercept at 1. Remember how we sketched the graph? If this number here is equal to 1, then that would mean that the graph goes through y at 1. So we move 1 to the right according to the run, and then we move 3 up to this point here, and then we'd have the graph that goes something like that. And if it was, let's try doing the negative thing, but then putting the negative in the bottom, or in the denominator rather. Whenever there's a negative sign in either the run or the rise, the numerator or the denominator, what it means is that the graph is gonna go opposite to the normal positive direction. So the positive direction for x is right, the positive direction for y is up. So if there's a negative sign, then it means it's going to be going left. So it means the graph goes left 1 and then 3 up, since the 3 is still positive. 1, 2, 3. And then for this side, for now, when you want to go to the other side, right, when you're on the right side of the x-axis, the positive side of the x-axis, then what you can simply do is you can move that there, because I hope you guys know this. 3 over 1, or negative 3 over 1, is equal to negative 3 over 1 is just equal to 3 over negative 1. This is basic fractions and negative numbers. I hope you guys know this already. If not, I'm not sure if I have a video on this on my channel in the future. But like I was saying, for the positive part of the x-axis, what we're going to do is you're going to put the negative there in the numerator, in the top part of the fraction. Then it moves so that we can move right. So it's 1 right and 1, 2, 3 down. So we can basically just connect these. It's not going to be a perfect line. Sorry guys, the line isn't perfect, but yeah. So guys, it's possible to tell whether two lines are parallel using only their slopes. To remind you what parallel means, it just means that two lines will never ever cross, and that the distance between them at every point is the same. So the way you go about telling whether two lines are parallel using their slopes or gradients is if the gradient of the one line, let's call it m1, is equal to the gradient of the other line. So let me show you guys. So let me draw a graph to demonstrate this to you guys. So if we have these two graphs, we can see that their slopes are the same, because the amount by which the y value increases in a given x distance is the same. And that is the definition of a gradient actually. And that is just the other way of saying the rise over run. And so I hope this helps you visualize why any two lines with the same gradient, or rather equal gradients, are actually parallel. And I'm going to teach you another thing that you can determine using the slope or gradient of lines, and that is whether two lines are perpendicular. And to remind you guys what perpendicular means, it means that two lines intersect at right angles to each other. And the way to determine that using their slopes is using this formula. If m1, which is the slope of one line, and multiplied by the slope of the other line is equal to -1, then the two lines are perpendicular. I'm not going to give you the same visual demonstration of that. Instead, what I'm going to do is I'm just going to go into Desmos and show you guys. But before we go into Desmos, let's just come up with values. Let's say m1 is equal to 3. You guys can tell I like 3. Therefore, we want 3 times m2 to be equal to -1. And then using algebra, we can divide both sides by 3. Then we're left with -1/3. Then we're just going to plug in two graphs, with the graph of the one having a gradient. We're going to plug in two graphs into Desmos, and the slope of the one will be 3 and the slope of the other will be -1/3. So here we have the graph y is equal to 3x and y is equal to -1/3 x, and as we can see here, they do in fact intersect at 90 degrees. Unfortunately I don't have a protractor. You guys can just, if you want a proof of this, you can look for a proof online. I'm not really certain or how to prove it, but yeah, we could, for example, add 2 to either graph, or even just to the one graph, and we can see that it's still at a 90-degree angle, and that demonstrates that it's only the slope that determines this. A quick way of determining the slope of the other graph. Let's say you're given the slope of the one line and they tell you to determine the slope of the other, and you just you just quickly want to do it, and your teacher isn't that strict about showing every single step. Then what you can remember is that all you have to do is you put a negative sign in front of this number here and then put it in the denominator, and that is the trick. If you remember, the number was -1/3, and that proves that my quick little shortcut, -1 of 3, -3, sorry, becomes, and then put it in the denominator, and then that becomes m2. Thank you guys for watching. I'm going to have another video where I go into more examples of functions, including slopes and all sorts of other sketching of functions. Please like and subscribe. Thank you.